Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good evening. So today I would like to discuss about our test. Alright, so this is the first question actually. Right, the first question is asking you to construct a truth table. Alright, so in order to know how many how many rows to be constructed for the truth table, you have to use this formula. This one. So you have to use this formula. 2 to the power of n, and the n here is numbers of variables. And here is numbers of variables. Alright, and in this question there are 3 variables: P, Q, and R. Hence, numbers of column will be 2 to the power of 3, which equal to 8. Right? So what you can do is do the P, do the Q, and then we have next is negation P. Alright, and then next you have P, if P, then Q, and then you have R, and then you have if negation P equal to R, then R. If negation P, then R. Then the last one is if P, then Q. R, negation P, then R. Alright, then line here, and then here. So okay, we have eight rows. So one row, then tak payah bahas row. Right, so the first row is we have 0, 0. Alright, you have to construct this first. So you have P0, Q0, and R0. Next is you will have 0, 0, 1. And then you will have 0, 1, 1. Okay, so basically this is our second row. Okay, have to be very careful. Okay, and then the third row, so must be very careful. Yeah. Okay, and then we have 1, 1, 1 here. Okay, tangan tak betul. Okay, we need another 4 row. rows. Right. So now we need lagi 001, 001. We need 0, 1, 0 here. Okay. And then we need 1, 1, 0, 1. Okay. Have to make this one better. 0, 1, 0, 1, 0, 1. So 1, 2, 3, 4, 5, 6. 2 rows to go. Alright. And then we need also 1, 1, 1, 0. So we need 1, 1, 0. 1, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, Alright, okay, and now we have negation P here. So negation P here is 1, negation P here is 1, negation P here is 1, negation P here is 0, and then 1, and then 0, 0, 0. Alright, if P to Q, this is what? 1. Saya salah kosong. It is 0. Yeah. So here is 0. Same goes to here 0. This is 1. This is 1. This is 1. This is 0. This is 1 and this is 0. Alright. And then negation P to R. So now look at here, negation P to R. If P and R here is 0, and then 1, and then 1, and then 1, and then 0, and then 1, and then 0. Oh, sorry. This is 1, sorry. This is 1, this is 1. Okay, and then this one is negation P to R, 0, 1, 1, 1, 0 here, and then here is 1, this one is 1, this one is 1. Alright, and then P to, if P and R union with negation P to R, so union here, this is 1, 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 and this is 1. So the answer is so the answer is this. Alright, so this is the answer for our first question. Right. So for our second question, um, I ask all of you to show that this statement is a tautology or not. Alright, so what tautology mean is this statement must be equivalent to true. Alright, that is the meaning of tautology. So the first thing that you can do in this presentation is you can settle this one first. Alright, so by using logical equivalence, this one, table 7, so by using this one, okay, it's P to Q is equivalent to negation P or Q. Okay, so in this case, the P and Q here, you can assume this as P. And the P here is the Q, right? So now, what you can do is P and Q to P is equivalent to negation P or Q. Alright, and then in here, by using the De Morgan law, you may expand this presentation. It will be negation P or negation Q or Q. This one by using De Morgan. Alright, by using De Morgan. And then here, so from here, okay, you can have the bracket here and you can group the Q and Q here. Alright, and then by using this one, negation law, which shows here P or negation P is true. Okay, so by using negation law, This will give you negation P or true. This one is by using negation negation law. And again by using this one, identity law. Sorry, by using domination law, P or true is equal to true. So we can conclude that negation P or true is true. So this one is by using domination law. So once you have this, it shows that this statement is tautology statement. All right. This is for question number 3. So I skip question 2A and 2B because I think every one of you get correct for both questions. All right. Okay. All right. So in this question, I ask you to determine whether this statement is a tautology or not. All right. So first of all, what we can do here is we try to simplify the simplest statement. So in this case, we have to change this process here into something else. So to change this, we are going to use this one. All right. So negation Q and if P then Q and then negation P. This one can be rewrite as negation Q and so this one we change to negation P or Q. Oh, change to negation Q then P. Then we try to make this less complicated. So by using the distributive law, this law, right? So this one is N R. So by using the distributive law N R, this one, so this statement will be changed into negation Q and negation P, close bracket, and R, negation Q and Q. Alright, then negation P. Okay, and then this one is by using distributive law. Alright, L is this one is law lah. law. And then here, okay, then now we have to settle this part pula, this process pula, alright. The implication. So we are going to use this one as well. So now we are assuming that this presentation as P. So now all this presentation will be negation. This. This one is by using table 7. Alright. And then next is we implement the De Morgan law. So now this will be changed to Q and negation P, and this is negation Q and Q R negation P. This one by using De Morgan law. Okay, in exam you have to write it full in full. Okay, Morgan. And then here this that one so then okay, you have this one, and then this for this one again we are going to use the De Morgan law for this part. So get the negation again, negation Q R P, close, and negation Q and Q R negation P. And then here by using this one is for De Morgan, and then we use the negation law, then here it will left with Q R P and negation Q and Q R negation P. Okay, so now I'm going to settle that part. Okay, so now in this part we can also use De Morgan. So now it will be Q R P our P, and this one will be Q. Okay, negation, negation, and Q, and then R, negation, Q, R, negation, P. Okay, and then here we can rewrite all this presentation by using commutative law. By using commutative law, it will be Q and Q, R, negation Q, R, P, R, negation P. This one is commutative law. Okay, and then here we left you with Q, R, negation Q, and this one is R, P, R, negative P will give you PR negative P, PR negation P, P will give you true, so this one will give you true. Alright, and this one will give you true, so true or true will give you true. So this statement is a tautology. Right? And you will use the negation. This one is double negation. Right? So that is for number 3. Alright, for our next question, which is question number 5, I'm asking you to simplify the statement, this statement. Alright, so you have seen this presentation, this statement. So now we might use definitions to rewrite this presentation, this statement. So it is A minus B or A bar. So A minus B is equivalent to A and B bar. Alright, so this one can be rewrite as A minus here, change to N, and then everything here will be B or A bar, everything here includes. Alright, and then the next thing that we can do is use the is use this one. we have to get rid of the first bar here. Okay, we want to get rid of it, so we can use the De Morgan law. So now we copy this, and then now to get rid of this, we use De Morgan law. This one does not is R, so we use this one. Alright, so we left us with bar here, and then bar here. A. Okay. Alright, then we use the complementation law. So this one, we'll use this one is De Morgan, and then now it's A and B bar and B A. So it is what is now? Complementation law. Complementation law. Alright. Okay. And then here it will be A and A. So since that both sign here is NN, so we can use the associative law to rewrite this presentation. So it can be A and B bar. So this one will give you adalah associative law. So now E and A will give you idempotent law. By using the idempotent law, so this one will be A and B bar. So this one is idempotent law. So the simplest representation of this one is this. Right? And then so for this one, again, you have to get rid of the first bar. So we can do it by using De Morgan. Is it? Yes, by using the De Morgan law. So by using the De Morgan law, this one will be changed into this, and B bar bracket and A and B. Alright. And then by using the double complement law, so this one is by using De Morgan. By using the decomplement law, this one will be changed into A and B bar and A and B. So if you look into here, we can use idempotent law, and we can use the associative law. So if you notice here, all the operation here are all the same, n and n. So we can use associative law. Alright, so by using the associative law, this one is double complement. Alright, by using the associative law, this one can be write as A here, and then an A here, and then B bar, and then B. Alright, one thing that I noticed when I mark your test, some of you doing like this. I use this example. Alright, and some of you do something like this. This is the original. This is the one that you get after you do the double complement. So you have this statement. Then what you do is you take this A to be in front. Alright. Sorry, not the E. You will get confused. So some of you rewrite rewrite, you take out this one and you write as the first operation B bar, which is this one is incorrect. Okay, so what you have to do is every time when you come up with this statement, you have to bring this one, the first subject, as a first subject. Okay, and then for this one, you can take this one to be in here, and then this part to be here. Okay, and then this part must be here. Alright. And then by using so this one is A and A, so we see where is A and A. A and A is equal to A, so this one A and A will be equal to A, which is just now that is the idempotent law. So by using idempotent law, A and A will be A, and then will be N, so B bar and B. So just copy this one. So you get this one by having the idempotent law, and then B bar and B, B bar and B, B bar and B. Oh, this one B bar and B will be equal to empty set. So this one, by using the complement law, this one will be empty set. So A and empty set. So is by using the complement law. So that one will be give you an empty set. So this one is an empty set. So the result is, so the simplified statement is empty set for this question. Okay, so for the first one was asking you how many respondents love to have coffee. That's all. So for the first one, we can group actually all of this information. So for the coffee, there are categories for coffee only, and there are respondents who love to have coffee and tea. So coffee and tea, and then there are respondents who love coffee and tea and also juice, this category, and there are respondents who love to have coffee and juice. All right, and then same goes for the tea. For the tea, this one, so there are category for only tea, and then there are respondents who love to have coffee and tea and coffee. All right, and then some of them also like to have tea, coffee and juice, and some of them also like tea and juice. All right, and then for juice also, some of them like to have only juice, and then some of them like to have tea and juice, and also some of them like to have coffee and juice, and some of them like coffee, tea and juice. All right, so for the first question, you may use this one. All right, so the number of people who love only coffee is 25, and then who love coffee and tea is 9, love coffee, tea and juice is 16, love coffee and juice is 23. So the total here is 70. 72, 73. Is it 73? Yeah, 73. All right. So for the second question, how many respondents love tea or coffee but not both? So in this case, these are the total who love coffee. Then now we may get the total who love tea. Tea, only tea 5 and 7. So 5, 7 is 12. Alright. Plus tea and coffee. Tea and coffee is 9. This is plus. Coffee, tea and juice 16. Tea and juice 12. Alright. And the total here is 12 plus 9 plus 16 plus 12, 15. It's 49. It's a 49. However, these two values consist of people who love both. Alright? Who love both. So, the question asks how many people who love coffee or tea but not both. So, and in this group, you can see we can extract which one will have both, like this one, coffee and tea. So this one we can remove this one, coffee and tea. We also can remove this one. So basically this one, the 9 and 16 will be extracted. So 73 minus 9 minus 16. Alright. Same goes to this one. Tea, coffee, remove. Tea, coffee, remove. So it left with 49 minus 9 minus 16. How many left? So this one is 48. This one is 24. So total these two value, you will get 72. So this is the answer for those who love coffee or tea but not both. Alright. And then the next question is, how many respondents only like juice, coffee or tea? Okay, so since that there is a keyword only like, so it means that they only like coffee, tea, juice. Alright, so for the third question, it only asks for this part because there is a keyword only like. Okay, so for the C, you have to add this part. So the answer is, so 28 plus 5, 20 plus 25 plus 7, you will get 65. Alright. And for the last question, how many respondents do not like all juice, coffee and tea? So now you have know the total of people who like coffee and tea. This one, 73, 74. Alright. So now what you have to do is you have, because our number of respondent is 150, so 150 will be minus with all the number here, right? So 150 minus 5 minus 12 minus 28, minus 16, minus 23, minus 9, minus 25, minus 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay. And you will get the answer is 25. Alright. So that's all for the test, for the question, for the test, the answer for the test. Alright. Okay.